Hello, everyone. My name is Driti Rajkumar, and I'm a junior at Portola High School here in Irvine, California. My project is all about evaluating the phage antibiotic synergy of bacteriophages from River Ganges against Pseudomonas aeruginosa infections. So let's get into it. Back in fifth grade, I did this project where I put a piece of meat in Ganga water and a piece of meat in tap water, and I measured the opacity over time. Over a few months, you can see that the tap water was much more opaque, while the Ganga water was much more clear. Why is this, you may ask? Well, this is because Ganga water is filled with something called bacteriophages, or viruses that can kill bacteria. And I was so lucky and able to test this in a lab this year. I hypothesized that water from the Ganges River would be able to inhibit the growth of Pseudomonas aeruginosa because the Ganges River is a potent source of these bacteriophages. And I also speculated that the phage antibiotic combination would be the most effective in preventing bacterial growth compared to using them separately. So let's unpack my results here. Part one of my experiment involved an OD600 where I took the OD over 4 hours of 4 solutions: sterile water, Ganga phage enriched once, Ganga phage enriched twice, and a known phage from Case Western called OCP2. And the results showed from the OD that the Ganga phage enriched twice and the known phage had the best results in killing bacteria over time. To make sure of this, I measured with CFU, or colony forming units, where I plated the bacteria. I went with dilutions for sterile water and the 1 times enriched Ganga, and you can see there was still a lot of bacteria present. Meanwhile, I had to plate the 2 times enriched Ganga and the filtered OCP2 without dilutions because of how little was present, and this is also shown on my bar graph here. Part 2 of my experiment involved testing for synergy with phage and antibiotics. So the therapeutic range for gentamicin in serum is about 5 micrograms per mil to 10 micrograms per mil at peak levels. And I found you only need 3 micrograms per mil of gentamicin combined with 1 to 100,000 dilution of gangaphage to be just as beneficial. How promising is that? You only need about half the amount. So because of these amazing results, I'm so excited to say that in the near future, I'll be looking forward to doing in vivo studies on rats, mice, and hopefully eventually humans. I mean, millions of patients die every single year because of infections. And with the rise of multi-drug resistance, meaning our bodies are becoming more resistant to antibiotic treatments, we need phage therapy to help us out. So I'd like to thank Carl Laboro, Professor Arnricht, Professor Eric Perlman, Yasmin Solano, and my incredible parents for helping me out. This is the first study to ever use an FDA-approved antibiotic and combine it with phage from the Ganga River. It's a cost-effective way and a natural source of phages to help fight these infections. So thank you all so much for listening.